Faço parte do time da Ethereum Brasil, assim como a Carol, que também está aqui presente. Esse workshop vai ser em inglês, mas a gente tem um chat aqui, quem tiver alguma pergunta, ficar com dúvida em alguma coisa, manda no chat. Google Translate ajuda bastante hoje em dia, dá uma traduzida, manda no chat que o professor vai ajudar. E é isso. Vou passar a palavra pro professor, ele vai começar a apresentação em inglês, tá? Quem tiver qualquer dúvida, pode perguntar para ele. Hi, Pete. I was introducing myself to everyone in Portuguese, and I was telling them this workshop is in English, but as we have a chat system here, if they have any doubt, they can text you, and sometimes it's easier to make a question and to answer on the text, and Google Translator can always help. So I will ask you to introduce yourself, talk about a little bit of Aleph Zero, and start your workshop.
Yeah, sure. So like Esther said, unfortunately, I can only do a workshop in English. Well, I can also do it in Polish, but I don't think that's doing anyone any good. I work as an ecosystem tech lead at Aleph Zero. I'm actually going to talk about Aleph Zero a bit as a part of my workshop, but basically we are a layer 1 chain with, we're building on top of Substrate, but with our custom consensus algorithm called Aleph PFT, which is like up there with the fastest ones, and the performance overall is great. Also, right now we're heavily focusing on the privacy features, and of course, last but not least, the chain features smart contracts in Ink, which is something we're gonna take a look at today. But actually, quite a lot of what I talk about during the workshop is also applicable to like Solidity or programming in general. I kind of try to make this, accessible and interesting to everyone. How do I access the chat? Oh yeah, yes. I mean the Polkadot one. Yes. Well, parity one. So it's if you know Polkadot or any other chains in the Polkadot ecosystem, I think you'll find this familiar. Although, well, we do have some differences, so I hope you will find this interesting. So without further ado, would you mind if I shared my screen, because I've got some slides. Yeah, there's some stuff I need to. Okay. Can you see my screen?
Yes.
That's perfect. So the issue is that when I present this, I don't actually see the chat. So maybe I'll tap quickly. Actually, if I do this, it should be all right? Yeah. Okay. Awesome. So the workshop's title is Safe and Robust Smart Contracts in Ink, because I wanted to focus and underline the importance of basically writing safe and robust code. Just starting at the level of the programming language itself and how you write your code. And I think this leads to better and safer smart contracts. Every time I start a workshop, I quote this definition, but the point here is that treating a smart contract as a contract in a traditional sense is valid to some extent, but also can be quite misleading. So I basically think of them as programs that execute on the blockchain, that kind of treat the blockchain as a computer, which is actually quite a good analogy, because the blockchain has a runtime, the blockchain has storage, so it's kind of similar to like the models of computation that we know from I don't know, computer science courses. So obviously, once you equip the blockchain with smart contract capabilities, you make all the logic programmable. So you can start to build interesting use cases, of course, starting with DeFi, so decentralized finance. So kind of like traditional finance, but without a trusted intermediary, without censorship, and with all the democracy. And also, this gives way to some additional additional ideas and additional instruments. A very interesting space where you could actually apply smart contracts is the whole digital identity area. So stuff like KYC and KYB projects, or the distributed ID in general. Very interesting. More on the enterprise side, we have supply chain management and provenance tracking. Also, somewhat of a hot topic always, I would say, certificates of ownership. So, well, I would say traditionally NFTs, of course, but it goes actually, the use cases for NFTs can be quite interesting, starting with art. So like, verifying authenticity or ownership of interesting art pieces, ownership of real estate, and kind of like shared ownership of real estate, software licenses and ticketing software can all actually leverage this mechanisms. And of course, it doesn't end there. You can easily come up with your own use case, which is of course what I encourage you to do if you get interested with ink and start coding. Now, as I think it was in the Spider-Man movie that with great power comes great responsibility. So, well, it's the same thing with smart contracts. The exploits do happen, and well, as programmers, as DeFi users, it's good that we try to limit the impact, try to write safer code, try to be more responsible in the actions we take in the Web3 space. So from the programming side, I think we can formulate this, and this is sort of a joke, but the grand theory of hacks. So I think that the exploits basically happen in the places where you don't know what your code does, and or are not 100% sure. And this sounds very trivial and kind of extreme, but it actually works quite well. So, the examples of what we would like to avoid, and I'm actually going to show how using a decent language with a decent compiler and adhering to good programming practices can actually help you, minimize this uncertainty in your code. But definitely the things to watch out for are input not being validated, right? So basically any time a program, not only in a smart contract, but any program accepts user input, it needs to be validated against the expectations or against what's allowed. So classic examples would include some JavaScript injections or stuff like, or SQL injections, but it basically any user input needs to be like really carefully validated. Disclaimer here, I come from a functional programming background, so I kind of care about this a lot, probably more than the average among programmers, but hey, let's say it. I think anything that mutates the state of the contract or the state of the program actually is possibly unsafe in different meanings. So, either unsafe from a concurrency perspective or unsafe from like the being a vector of exploit perspective. And this might seem even more extreme, but any place where the code repeats, either, be that a for loop or a while loop, or especially any sort of recursive, so like a function calling itself directly or indirectly, or a contract calling other contract, and this possibly forming a loop, that can be quite dangerous, as we're going to see in just a moment. And also, as we're going to see in a moment, any catch-all execution flows or fallback methods or implicit operations are possibly very unsafe. I'm going to check the chat real quick. Okay, yeah, no questions. That's good, but don't hesitate to ask them. I'll be checking the chat once in a while. Now, so as kind of a very motivating example, I like to describe the very basics of the DAO hack that happened a few years back, and of course now the whole the whole landscape looks a bit different. Stuff has been since fixed, but this basically illustrates a very simple reentrancy attack that was exploited to actually steal a lot of funds from the contract. So, well, let's say we have this DAO contract that for the purpose of this example basically has only two methods. It has the deposit method where you can actually deposit some ETH, and it has the withdraw method that, well, you can withdraw what you've deposited. And of course, we have this attacker, and I'm calling the attacker Malice because it's a twist on the classically used, Alice and Bob in names in cryptography. But let's say Malice wants to attack the DAO, and like I said, this is like a high-level overview of how this happened, more or less, serving only as an example. But so, how the attack went through was someone deposited a certain amount of ETH. Well, let's say it's 100, just for easy calculations. But someone deposited the 100 ETH, and then they wanted to withdraw the 100 ETH. Oh, but actually, an important thing is that it's the attacker is actually a smart contract itself, right? So after depositing, the contract asks the DAO contract to withdraw the amount they deposited earlier, and of course the DAO contract checks if the balance is enough, and then does a transfer of 100 ETH back to the attacker contract, as it should. But what's key here is that the DAO contract only updates the balance of the account after the transfer has completed. But in order for the transfer to be completed, it has to be handled on Malice's side. And the way it works in Solidity in ETH is a contract can have a receive method. When it receives a transfer, that can handle the transfer, or it can have a fallback method that can actually contain arbitrary logic, including cross-contract calls. So the attacker's contract actually in the fallback method contained another withdrawal call. And if you recall that the balance of the Malice account was updated only after this whole thing has finished transferring, you will notice that this forms an infinite loop. Of course, the attacker had to check if the balance of the DAO contract has not been exhausted down to zero, because if it tried to withdraw under zero, of course, this would throw an exception and abort the whole loop. But this basically formed this reentrancy loop that allowed them to drain the DAO contract really fast, right? So this basically goes to illustrate that very simple mistakes and sort of like, well, something that can be very easily improved can actually have very drastic consequences. So the point I'm trying to make here is it's actually worth spending a bit more on writing the code than fixing the aftermath of exploits and errors in production. So now moving on to the actual smart contracts, we're going to be looking at Aleph Zero, which I already introduced, but like I said, layer 1 proof of stake blockchain, actually nominated proof of stake blockchain with strong focus on privacy. We're creating the liminal privacy framework. You can read about. There's going to be some links in a second. With sub-second finality times and block times, extremely low transaction costs. So for smart contract developers, this is actually quite important because, well, your contract will quite possibly be doing quite a lot of transactions, and the gas fees are actually also a factor here. So this is very low on Aleph Zero, and well, of course, it has smart contracts in Ink. So we're gonna introduce Ink, and Ink as a language can be used, of course, on other chains that support it. Now, here's a bunch of useful links. The first one is the main website of Aleph Zero, and it actually contains references directly or indirectly to all of the other links. The second one is the documentation on Gitbook, and then the developer portal, which also contains a handful of useful links. Test A0 Dev is the developer wallet, so maybe not the best user experience, but like feature complete if you want to interact with the chain. Then the contracts UI, so a graphical user interface way of interacting with the contracts, and something really useful, so the JS API to talk to the chain, to get some information from the chain or do transactions, which is gonna be really helpful if you deploy your smart contract and want to interact with it from your app, from your web app. Then this is probably the thing you're gonna use. So I'm just posting it here for reference. Now, so Ink. What is Ink? So in contrast to, for example, Solidity, Ink is not a separate language, but instead it's an embedded domain-specific language built on top of Rust. But, well, putting it in more intuitive terms, it's basically a subset of Rust with some additional macros that are contract-specific. So this has some benefits because, well, for example, if you already know Rust, you can basically switch with no effort to Ink. Actually, if you know Solidity, you also can switch to Ink very quickly because you will find most of the concepts very familiar. But then, being a subset of Rust, it has the same benefits as Rust. So being a modern language, like integrating a lot of programming language research into the language, a very type-safe language, as type-safe as a language, I would say as type-safe as language can be without sacrificing developer experience, and how quickly you can write code. Memory safe with a very interesting and performant approach to memory safety. The tooling is quite good, like building on Rust tooling, and of course quite universally liked by developers, as evidenced by the Stack Overflow surveys year by year. It seems to be the hype right now. And then what's important about Ink is that it compiles to WASM, so WebAssembly, which of course comes with its own set of benefits. It's basically, it can run everywhere, and it's fast and secure. Very nice standard. This table might seem daunting at first, but it's here to illustrate that basically most of the concepts you will be familiar with from Solidity, from your experience with Solidity, can be applied in Ink without too many modifications. Of course, there's a different syntax and a different type system, but you should feel familiar if you know the ideas. Actually, a notable difference is the difference is in storage entries. So Solidity uses 256 bits as the only possible size of a storage entry, and in Ink this can be variable and is variable, which has some good performance benefits. So this is just an illustration. Actually, treat this as a picture, because this is like an overview of what you need to do to jumpstart your Ink development. So you install some dependencies. You install Cargo Contract, which is basically a build tool and package manager and everything for Ink smart contracts. It's of course building on top of Rust's Cargo, which is the same thing but for Rust. Then you use Cargo Contract to bootstrap a new contract, and it comes as actually a ready to deploy contract, which is actually quite important in how we approach the following slides, because, well, you have all the scaffolding after writing the Cargo Contract new command, right? So you don't really need to memorize all the letters in your contract. You actually need to only focus on the general idea, and the rest will be basically provided for you, and you can just modify it and treat it as a reference point. So even though the number of macros and new syntax can seem daunting at first, it actually is not when you actually start using Rust, ing, and cargo contract. Then you, of course, compile your contract. Starting with the tests, obviously, as good programmers do, and then you build it, and you're ready to upload it to the chain. It produces like essentially two artifacts. So the actual WASM file with the code of the contract as a WebAssembly format, and the contract's metadata, which then the contract explorers and the contract's UI and your users in general will use to know what methods to call on the contract and what they do. It's sort of like a documentation and like a reference for the methods inside the contract. And as a convenience, the two files are bundled as one contract file. So we're gonna take a look at how you upload the contracts to the chain later. This joke is kind of maybe getting old by now. We're gonna create a simple ERC20, or as we call it, PSP22. Is basically the same standard token. Someone's actually now, I think, made a Pete coin on Aleph Zero. So but it's basically just a name I picked because my name is Pete, and we're making a coin here. So a very simple fungible token contract. So now the ERC20 standard is basically this ubiquitous standard for fungible tokens. And it's actually a very basic set of methods that or messages that the contract will have to be able to reply to in order to be treated as an ERC20 contract. And we're going to focus on just a few here right now. So the total supply is obviously, just that, the total supply. So the overall number of coins in circulation of your token. The balance of a specific account is basically how much of the tokens it has assigned and is able to transfer or spend. Let's forget allowance, and the most important function is obviously the transfer. So you can transfer some of your own tokens to someone. Events we're gonna talk about later. Jumping right in. This is what the contract looks like at a glance. There's some macros that are gonna be generated by the cargo contract new command. Actually, depending on the version of Rust and ing you're using, you might need to add a no main here after no std, but that's not very important. It's gonna be generated for you. Now the important thing is that a contract is basically a Rust module, which is declared like as mod and then the name. And the module is kind of basically a collection of things. So kind of similar to namespaces if you're familiar with C++. You can basically group stuff together under a common name. Now, in order for this to be a valid ing contract, it has to be decorated with the ing contract macro, which actually does a lot of stuff behind the scenes. Some of them being enforcing certain invariants as to, that the contract needs to have at least one method, at least one constructor, at least one message, which is not the same as we're gonna see in just a moment. At least one constructor. It also gives you some handy aliases that we're going to use in just a second. And of course, by the way, the things starting with hash signs are Rust macros. Those are not comments if you're coming from the Python world. This is how you write Rust macros. So now, of course, the most important thing in your contract, aside from the logic, is its storage. And the way you declare it is you basically use regular Rust struct, which is basically similar to how you would define a class in other languages, or actually a struct in a language like C or C++. Now the important thing is that, of course, you can access the fields by typing, the usual syntax, so like the struct's name and dot and the field's name. But the structs don't have inheritance, which is, I think, it's a wonderful choice that Rust creators made. It makes a lot of stuff simpler and actually prohibits writing, abstractions that are over the top. The important thing for this is that it has to it has to be marked by the ink storage macro, and it needs to. Oh, I actually don't know if this is required, but definitely very very handy, and you absolutely want to do that. So deriving the default is basically allowing your struct to have like a default, like a zero instance that you can use to initialize it, and only then fill its fields with some specific values. And for our specific example, our storage will hold the total supply, and basically the sum of the mapping containing the mapping from every account known to the system to its balance. And the balance and account ID types are provided to us like for free by the ink contract macro that we've seen before. And and to use mapping, you want to use this Rust use statement, which is you might think of it as an import, but is actually closer to basically bringing some name into scope. It actually has no magic involved as imports in some languages might. This is just saying use this name, and now we're able to use this mapping type. Now after we have our storage, and our struct, we can attach some behavior to the struct. In our case, this would be the constructor and the messages that the contract will be able to kind of handle. So in Rust, you do that by writing impl and the struct's name. So this is saying, okay, this is a set of methods that this struct can perform or can respond to. The first one we're gonna take a look at is gonna be the constructor, which is basically a regular Rust method, with the only difference being that it has to be marked by this ink constructor macro, and it doesn't even have to have a specific name. By default, it's new because it kind of just makes sense, but you can actually call it anything you want as long as you mark it with the ink constructor macro. So this also means that the contract can easily have more than one constructor. It needs to have at least one. That's enforced by the ink contract macro. Now, in our case, and obviously the constructor needs to return the instance of our struct. We are using this. We could actually, instead of self here, write Pitcoin, but writing self is kind of a good practice, as it kind of works better in this, trait-based world where it's kind of more generic, but only slightly. It's also shorter to type if you're into this the developer economics. Now, what we do here is, when someone's creating the contract instantiating, they need to call the constructor. So obviously they are the contract's like owner, at least of this instance that they create. Now they need to set the initial total supply of the coin, of the token, which will be passed in the constructor as an argument. Now we initialize the balances mapping first to the default value, which for a mapping and actually any container is just an empty container of this type. Now then we try to find out what's the color of the contract by using this magic env method on the contract struct itself, but it's basically like a global environment of this Okay, it's an environment of this particular contract, allowing you to, for instance, as we see here, get the color of the contract, but also you can find out stuff like, for example, what's the account under which this contract is deployed. Now, as mentioned previously, the color of the constructor is obviously the owner of the contract. So into the balances, we insert a mapping that says, okay, when someone's creating this contract for the first time, they get the whole total supply. If then they decide to do some transfers, obviously this is going to get divided and more entries will be entered into the balances mapping. But for now, it's just that. And then we instantiate this struct. It's actually a shorthand syntax because you can... This is what happens when the values you put here, the variables, have the same name as the fields. You can also write like the field's name, colon, and then the value you want to assign. Now, this is kind of a side note, but I think it's very interesting. And even though in the contracts you won't have to dive really deep into how Rust manages memory, I think this is interesting. And well, to some extent, it's good to know when writing smart contracts. So, and that is how Rust manages memory. So the important thing is that the way Rust is doing that is avoiding the garbage collector altogether. So, garbage collectors come with their own set of problems. Like, for example, this Java garbage collector used to be, like a stop all machine that basically, once it fired, it basically stopped all the threads and started cleaning up unused chunks of memory. The smart pointers, this is also not how Rust is doing that. The smart pointers have lower overhead, but are kind of not really comfortable to use. Rust is introducing this idea of the ownership model, and it actually has some type theoretical basis. If you want to read about it, you can read about linear and actually, affine types is probably the closest one to this, but that's completely optional, only for those of you interested in type theory, I guess. Now, basically, the whole premise of the memory management system is that everything you allocate on the heap has exactly one owner, right? And the core idea is that if you, the owner here is not like a person, but more, think of it as the owner is a certain scope. So like a function or, most often a function. Now, the basic idea is that you can only access the data that you own. Or have been borrowed, but that's we're gonna see it in a moment. And basically, the Rust compiler won't allow you to touch or access anything that you don't own, right? So now, of course, you can transfer the ownership, and there's two ways to go about that. You can move something. So this is basically like gifting some piece of data, and importantly, this is actually very similar to pass by value semantics. So you just give away your value, and in Rust, importantly, you can no longer use it if you move it, if you give it away, and it has a lot of sense, like from a memory safety perspective. You might be familiar with std move from C++. Now, the second one is borrowing, which has slightly more, I would say, involved semantics, but yeah, it's also you can it's probably less restrictive in a way. So this is very similar to passing by reference from other languages. And now the cool thing about this is that you achieve full memory safety. That's ensured at compile time, and you have virtually zero overhead. Rust in general has no runtime overhead as some languages might. Now, to show a motivating example, albeit a very simple one, let's consider this extremely simple program. It has a struct called foo with just one field. It's some number, and we have this function that into the function we are passing a struct like that, but just a plain pass by value. So this would be the move semantics, right? And what we want to do is take the field of this struct, add 1 to it, and return it. So we basically in the main function, which is like the main entry point, we try to instantiate the struct, which is of course okay, and then we try to call this function on our struct, which also should make sense. And then we try to print the contents of basically of this struct. So yeah, it all seems to make sense, and yet we get a compilation error. And actually, Rust compiler, it can be a pain in the ass because it's pretty strict, but it also is pretty helpful. So it actually tells us exactly what's wrong, right? It says, well, you're trying to borrow a moved value, which is basically to say, okay, you're trying to access what you've already given away after you've given that away. So, and the nuance here is that you can actually make this legal if you allow the foo type to be copied, but let's not focus on that for now. So, like I said, once you move the data, you're no longer allowed to use it. And of course, we can try the second method, right? So we can try to borrow the data, so kind of pass by reference. Same code, the only difference being this. Oh, sorry, I clicked. The only difference being this ampersand sign here before the foo, which is saying, okay, this is borrowed into this function, right? So it's the ownership is not transferred; it's just allowed to mess with this structure for a while. Now and we are doing a slightly different thing, because right now we are modifying this in place. So now, what happens is, okay, yeah, we're passing this by reference, and then we're trying to print the field, which would make sense, but the thing is that right now we're modifying the field, and Rust compiler is saying, okay, you're modifying this reference, but you didn't tell me it was mutable. So, hey, this is an error. And you need to mark it as a mutable reference in order to be able to mutate it. And this is actually, connected to what I said earlier about how mutating the state is quite often dangerous. And like Rust is trying to help you here by, making you explicitly say that, hey, I'm going to be mutating this reference. So now, basically, a working version of this example is like that. So the pass by reference is now accepting a mutable reference, and when you pass this reference, you also need to say, "Hey, I'm passing this mutable reference," and now it works. So this is basically the idea behind the ownership model and Rust memory management. There's of course a lot of nuances at play here, like what happens if you borrow a value from someone and then return it from a function. So. Like in the real world, this wouldn't be a cool thing to do, like borrow something from someone and just give it away. So it's kind of gets tricky in Rust. But fortunately, when writing smart contracts, I don't think I've ever seen a case where you would have to do stuff like that. So that's pretty cool aspect of Ink, that it's a subset that's small enough, and the domain actually is small enough that you won't have to worry about it. So. Coming back to our actual smart contract after this quite long detour into Rust memory management, so we have these Ink messages, right? So any method on the class that we mark with Ink message is basically it has to be a public method, by the way. That we mark with Ink message is what our contract can respond to. Like you can, from an outside world, so like from the contracts UI or from some explorer, you can issue basically a transaction to the contract saying, okay, execute this message, and it will give you something back. So the messages we're looking at here are the simple ones because they only get something from the contract. They do not mutate the contract state. And it's actually quite different in the UI after you see that. But yeah, the first one is, as we've seen in the standard, it has to be able to tell you the total supply. So this is simple. It just, the self is this is the same as in Python. It's just the reference to the contract storage itself. But importantly, in an inc message, the self always has to be passed by reference, right? So here we just return the total supply, and notice that in Rust you have this implicit return thing where you don't need to write return if you're returning a value, but basically the last line of the function will get returned. Yeah, so sorry, I see that there was some, if you avoid using the derive your node. Yeah, I think you actually you definitely would be able to initialize your struct like that. Sorry, that's about Rami's question. Yeah, but I'm not sure whether the contract macro actually doesn't require the contract storage to have a default instance. I don't know because I never checked. I always write this default instance. I can check later. So yeah. So the more interesting of these two methods is the balance of, because it's actually a simple and beautiful idea that we'll see at play here. So what this method balance of does is basically you give it an account ID, and it will go into the balances mapping and try to find the entry for this particular ID. So the balance of that account. And now we are using, self balances is the mapping with the balances, and we're using the get method, supplying the owner, and we're trying to get the balance associating with that owner key. Now, this can either return something if this account is already present in the mapping, or it can actually return nothing because, not every account has to be present in this mapping, right? The contract might not have seen that before. So what this method returns is something we're gonna inspect in more detail in a second, but it returns this result type that basically can have two variants, either okay with the actual value of what you're looking for, or error with some error. Oh, sorry, this actually returns an option, so like either some value or nothing. But anyway, we can, on this result, there's like kind of two variants. We can use this unwrap or default method, which basically says, okay, if the value is this something, is the value we're looking for, just return it. If not, return the default value for that type. So if that's here, that's a balance, and the default value for balance is 0, right? So this is actually a beautiful idea, because as we're gonna see in a moment, if someone has never used your contract, their balance will automatically be kind of treated as 0, which then really helps you when implementing the transfer logic. Now, yeah, the transfers actually are super simple, and I just wanted to do this graphic because I think the presentation looks way cooler with the graphics. But the transfer is as simple as this. So we have two accounts, both with balance of 1,000 Bitcoin, and now Alice wants to transfer to Bob 100 PC. So the way we go about it is, recall that we have this balances mapping. So effectively, what the transfer is we take the 100 PC from Alice and update her balance accordingly, and we add the 100 to Bob, and that's all that's required, right? Once we do that, the transfer is done, and it's actually not that different to what a bank transfer looks like in their databases, right? So with this simple idea, we can actually implement this, and you will see two methods here. So one is like this public API that just takes the account of the recipient, the to account, and the value that you want to transfer, and the account from which you transfer is actually derived again from this env method, just taking the color, and then you can call this internal method which is not public, to actually transfer from this account to another account. And the argument types are actually switched to references because of how WASM is treating the it's basically it's an optimization that has to do with how WASM works internally. But yeah, so and importantly, notice how so let's go through the logic real quick. I use this balance of impl, but I just copied it from my contract. Sorry, should be balance off for the purpose of this example. So basically, first we need to take the balance of the sender account, right? So this is called from here, and of course the balance that you have available needs to be greater than the value you're transferring, right? You need to have the funds. If it's less, then we need to fail with an error, and this is the Rust result type that I'm talking about. So if something went bad, we're returning this error variant that can contain a custom error. We're going to see that in a moment. But notice that we're not throwing any exceptions or disrupting the execution flow in any way. This is what I call the algebraic way of handling errors, which has a lot of benefits, I think. Now, once we've verified that the transfer is actually okay to be made, we can, update this. Remember how we took the 100 coins from the sender, from Alice. This is just it. So we insert to the from account balance basically what it was before, decreased by the value that the sender wanted to transfer. Now we need to take the recipient's balance, and this is the cool part, because if you recall how the balance of implementation will return 0 if an account is not known, imagine the to account is an account that this contract has never seen before, and so the to balance comes back as 0, and now when we insert to, the balance is mapping the updated value. If it was previously not present in the mapping, the to balance will be 0, and now it will just have the value that was transferred, which is exactly what we want to do. And the last thing we do is emit an event. We're gonna talk about this in a second. And importantly, if everything was okay, notice that we're returning this result type. We need to say, okay, return the okay type. That's gonna have some empty value because just everything went okay. Now, and this is, I think this is a great step towards writing your programs in a safer way. So handling your errors in a modern way, basically. It's not actually super modern because it was used in Haskell since, well, for like 50 years, but still, it's what's I think it's considered like up to date now. So what we do basically is we create this enum. So like it's like a variant type. It can be the error can be one of the constructors inside. So either a custom error with some message or insufficient balance if we were trying to make a transfer for more money than we actually have, well, more tokens. Allowance, don't worry about that. And 0 recipient or sender, basically if we put some nonsensical value as the recipient, it should fail. This is actually, I think, copied from some reference implementation of a PSP22 token. Now, this is a re-implementation of the result type that Rust has, called myResult, so that if you paste it, it won't cause any conflicts. Now, what's important here is that it's an enum that has two variants. So it's a result of some computation, which could have either went okay, in which case it just contains a value, or it could have errored, in which case we receive the error variant back containing some error message. It doesn't have to be a string, but sometimes is. It can be a custom error. And basically, in the pointy brackets here, we have the type parameters. This goes to say that those are basically generic parameters, type params that can be instantiated to anything you want and still will be type checked. The type keyword is just a type alias to make your life easier. If you're, for example, always using string as the error type, you can write like a shorthand notation and use this. Importantly, the type alias is not type checked. So I believe this is called a sum type. So it can either be the okay result or some error. So I would also like you to know how this is a lot more expressive than the Boolean type that's returned by regular ERC20 contracts, and they only usually fail through like requires and stuff like that. I don't think that's a very good way to handle your errors. Exceptions have been called the glorified goto, if you're familiar with this very old concept. Coming back again to our contract, an important aspect of the contracts are events. Of course, you should be familiar with events from Solidity if you've programmed that before. But well, in Ink, basically, guess what? You do a struct as previously, and you need to mark it with the Ink event macro. Again, you should be familiar with the Ink macros, that they put them basically everywhere. Now, events the struct has certain fields, and some of them can be marked with Ink topic, which is basically telling all the indexers or wallets or explorers that actually ingest the events from the contract to index these events based on that field to make it easier for lookup and whatnot. Oh yeah, this is actually, if you want to think about it, so this event basically tells us that, okay, a transfer happened, and we mark the from and to accounts as optional. So you can think about the cases in which a transfer has happened, but for example, it has no recipient, or it has no sender, right? It's interesting, but it happens. Yeah, so this is how you emit an event. This is actually a very basic version using the env variable. If you look through the example code at our, which is Cardinal Cryptography or Aleph Zero smart contracts, or some other smart contracts, you will notice that usually people use a more involved method of emitting events that works better with like multi-contract scenarios. Oh, and by the way, this sum type here is basically just like the result, but it's a result without the error message, basically. So the error information. So it's either some happy result or basically nothing. So this is good for stuff that may not yield value, but if it doesn't, it's not really an error. So you try to find something in a map and you don't find it, so it's not really an error. It's just, well, it wasn't there, right? So the option type is very useful then. Yeah, so like the remaining stuff that might be interesting and that you might want to look up later, because I don't want to dive too deep and make this too broad, is making your methods, your messages payable, because Ink and, well, actually WASM smart contracts allow you to transfer some value understood as the native currency of the chain. So in case of Aleph Zero, this would be A0 or T0 if we're on the testnet. So you can transfer the value to the method alongside the call, and then inside the method you can see how much was transferred. So you can take deposits this way, or charge some fees for the functioning of your contract. It can be quite useful. Now, testing is very important. I cannot stress this enough. And actually, Ink is cool in that it comes batteries included with quite a lot of testing functionality. So first of all, and your kind of first line of defense after the compiler itself with its type checker are the unit tests. So of course you're familiar with unit tests. Here they can be used to kind of test like the very simple granular behaviors of your contract. You write the tests, as you might have guessed, by using a macro. It's Ink test above a method. You also put the test in a separate module. But yeah, so unit tests are definitely very important and allow you to iterate really quickly and find, actually simpler of the mistakes. And then you also with the version 4.0 of Ink, and it's getting constantly improved, you're getting also the end-to-end tests, and I'm going to show you an interesting bonus later about how you can interact with the contracts in an interesting way. Now, this is a bonus, just because I really like those, those algebraic errors and those algebraic data types, ADTs, such as the result. So as it often happens, well, when you look at how we handle our errors by returning these results that can either be okay or error, you might think, okay, this very quickly turns into a completely incomprehensible, like a ladder of if statements or some pattern matches, and I would say, well, it would, if not for some useful shortcuts and syntactic sugars and whatnot. So one of them, not the only one, but the spectacular one is the question mark operator. So if you look at this, we basically have two functions that return different errors. And yeah, we could kind of do the pattern matches like in the main method here, but it's a lot of work, and we actually don't really want to do that. So yeah, what we can do is we can write this implementation of a from trait for. Oh, you're gonna see that this is the first one returns my error 1, the second one returns my error 2, so different types, incompatible. We can write a third error class, which is going to be like the umbrella error, and we can write conversions from the first error to the third error, and from the second error to the third error. And now notice that this is usually, once you're using Rust or Ink and its libraries, this is usually written for you. So I don't think you sometimes need to write it, but usually this is way less boilerplate than it would seem. Now, once you have these conversions, you can just, write your computations as if they never failed, but only supplying this question mark sign that basically tells the whole function to, okay, if it succeeds, then it's great. Just treat it as a normal, pure computation. If it fails, just fail the whole function. So then you're able to chain a lot of operations that might fail very seamlessly and with very little additional code. And then you will, if your conversion functions are okay, you will get a very meaningful error, which, well, I think is pretty cool. Actually, some other languages also use the question mark operator, and maybe not as cool. Now, deployment on the chain, I don't know how long we actually have. But yeah, it's like 1 a.m. already for me, so I'm just gonna use my screenshots and not do a live demo. So this is what the deployment on the chain looks like, and this is the graphical user interface version. So there is also the command line version. It's all described in our docs. Both are cool. This one is way nicer for the presentation. So you basically go to this contracts-ui.substrate.org, I think. Yeah. And the link is there in the presentation. I think it will be posted, so it's no problem to get this. So you need to choose the account from which you're deploying. You need to choose a name for your contract. And then you do a few steps. First, you select the contract bundle here, so the contract file that you get after compiling your contract, and the bundle will be in your projects folder, by the way, in the target/ink folder, so that you're able to find it easily. Now, after you do that, you have the chance to instantiate the contract. Note that uploading the contract is not the same as instantiating. So uploading is just getting the code to the chain, and then you can create multiple instances from the same code. So, but yeah, here we are just gonna create a new instance of the contract, and this basically means calling the constructor with the appropriate arguments. There's some values here which we are not gonna focus on. But importantly, the whole system performs a dry run of your contract, so kind of like a simulated run that's not actually modifying anything on the chain, but will give you the idea for first whether the contract is okay and will not fail during instantiation. Secondly, how much gas will be consumed and what fees will be incurred. Now, after you do that, you need to confirm submit the transaction sign. And then once you do that, you're able to interact with your contract. Notice that your contract, like I mentioned previously, has an account. And interestingly here, you will notice that for the mail messages that do not modify the storage, the UI doesn't even have to do a transaction to the chain. I think it just does an RPC call so that it's happens instantly. If you want to check the methods that you have available, this is the metadata file parsed here that we mentioned previously, and it contains, well, especially if someone took the time to write the documentation in a good way, then you will have your documentation here of all the methods, so you can choose the right arguments and the right method to call, obviously. If you choose a method that modifies the contract storage, as will be the case with the transfer method here, which obviously will change the storage mapping, you will need to choose the account to which to transfer. By the way, side note, it's useful to have more than one account if you're developing the contracts, because you will probably need a second account to test the recipients and everything. And this actually will require doing a transaction, so you will need to sign it and call the contract. And of course you can inspect the events that get displayed. Now, to finish things off, there's a lot of interesting projects being built on top of Ink, on top of Aleph Zero, on top of Substrate. One notable example, and especially useful to Ink developers, actually both newcomers and seasoned pros alike, is the Inkathon boilerplate, which basically gives you like a batteries included full stack application that has some smart contracts, able to talk to them. You're able to connect your wallet, so it's a really good way to jumpstart your development. It's made by one of our ecosystem projects, actually by Dennis and one of our ecosystem projects. Shout out to them. Awesome projects, awesome work. Secondly, a de facto standard for creating tokens in Ink is the OpenBrush library. Really cool. Now, if you're familiar with OpenZeppelin, this is a very similar thing, but for Ink. So if you're starting to write Ink smart contracts, sooner or later you will either use it yourself or encounter a contract that uses it, because it's super common in Ink ecosystem. Now, this is a bonus that I wanted to show you, just to show you what we're working on. It's public, but it's not really ready to. We don't advertise it yet, but hey, especially for you, this is a demo of an awesome thing done by one of our developers. This is Ink that doesn't require a chain to run, so it's super fast. It's as fast as any REPL you've ever used. Actually, one of the faster ones, because, well, things just happen so fast. I love it. Yeah, so basically this is the way for you to get to know Ink without, the whole kind of cognitive overhead on, running a chain instance or using a test net or something like that. Oh, how do I? Yeah. Okay. So basically, this would be it. I'm just gonna check if there are any questions real quick. Okay. Yeah. So thank you so much. It was really great to be here. Sorry I couldn't do the workshops in Portuguese. If I learn it, because I love the sound of the language. If I learn it, I will definitely come back and do another one. So yeah.
Maybe
thank you, everyone. If there are any questions, then by all means write them in the chat. And yeah, thank you so much.
Thank you, Pete. Did you see if there's like any unanswered questions to be answered on the chat? No. Okay. Thank you very much for your time, for helping the community to learn something new. I think everyone will be able to be in contact with you, and if any further questions comes around, you can talk to people and help them. And to everyone that is here, we're gonna put this workshop in YouTube with subtitles in Portuguese and trying to and share the presentation with everyone. Okay, thank you very much and have a good night.